These are notes for section 4.2. Section 4.2, page 214, 1 to 37 odd. So there's problem 16 or so. More. Answers. 4.2. Okay. So these problems look very much the same as section 1, but we're solving it by a different technique. Okay, so please notice there are still two equations with two unknowns. Okay. Two equations, but we're not graphing. We're doing it by something called elimination. Okay, so what is elimination? Well, we eliminate either the x or the y variable. So for number 1, x plus y equals 3, x minus y equals 1. What happens if I just add directly, just add straight down? Notice the y's would cancel out. 2x equals 4, divide by 2, x is equal to 2. Okay, then I plug back in to find y, plug in 2 here. 2 plus y equals 3, so subtract 2, y equals 1. So the ordered pair is 2, 1. Notice there's no graph anywhere, so we got this problem without graphing. Double check. 2 plus 1 is 3, 2 minus 1 is 1. Number 5, what happens if I add right away? This time the x gets eliminated. So it doesn't matter if you eliminate the x or the y. So x is gone. Negative y minus y is negative 2y. 7 plus 3 is 10. Divide by negative 2, y equals negative 5. Okay, then decide to plug back into this equation. You can plug back into either equation. X minus a negative 5 equals 7. That's x plus 5 equals 7. Subtract 5, x equals 2. So the ordered pair is 2 comma negative 5. Okay, now starting with problem 11, you have to do a little bit more work. Okay, for problem 11, it won't help to add right away. If you add right away, nothing gets eliminated. Okay, but in this instance, I'm going to multiply the top equation by 2. Notice if I multiply the top equation by 2, this will force this to become negative 2y. Then when I add the negative 2y to the positive 2y, they'll cancel out. Okay, so you might need to multiply one equation or the other by something in order to get the cancellation. Okay, so multiply this by 2, 6x minus 2y equals 8. Copy the second one. Now when I add them up, I get what I want. Okay, so now when I add them up, y's drop out. 8x equals 32. Divide by 8, x equals 4. Okay, then I decided to plug back into the second equation because it didn't have any negatives. 2 times x, 2 times 4, plus 2y equals 24. 8 plus 2y equals 24. Subtract 8. 2y equals 16. Divide by 2. Y equals 8. So 4 comma 8. Okay, 17. Somewhat similar. I want us to eliminate the x variable. So the original problem looks like this. 3x minus 5y equals 7. Negative x plus y equals negative 1. So multiply the second equation by 3. How come? That way this would be a 3x and this would be a negative 3x. Okay. So leave the top one alone. The bottom one becomes negative 3x plus 3y equals negative 3. So now when I add them up, the x's get eliminated. So this comes out to be negative 2y equals 4. Divide by negative 2, y equals negative 2. Plug negative 2 back here. I get negative x minus 2 equals negative 1. Too many negatives for me. I'll multiply both sides by negative 1, and they're all positive. X plus 2 equals 1. I like that a lot better. Then subtract 2, x equals negative 1. So my ordered pair is negative 1, negative 2. 31 is harder because of all the fractions. So this is the original problem. Okay. So I see denominators of 3, 4, and 6, 2, 3, and 3. I don't like that. So how about multiply the top equation by 12, which is the common denominator of 3, 4, and 6. Second equation multiplied by 6, just to get rid of the fractions. So 12 times 1/3 x is 4x. 12 times 1/4 y is 3y. 12 times this. Now 12 divided by 6 is 2. 2 times 7 is 14. Okay, 6 times this. 6 divided by 2 is 3. 3 times 3 is 9x. 6 times 1/3 is 2 times y minus 2y. And 6 divided by 3 is 2. 2 times 7 is 14. Okay, so much, much nicer right here. And here's our first instance where you have to multiply both equations by something. Okay? So I see a 4x and a 9x, not very comfortable, and a 3y and a negative 2y. So I decided to force both of these to be a 6, except this is a positive, this is negative. Okay? So I'll multiply the top equation by 2 on both sides. That forces it to be a 6y. Multiply the second equation by 3, that'll force it to be a negative 6y. So that way I get a 6y and a negative 6y canceling out. Okay, 2 times that, 8x plus 6y equals 28. 3 times all this, 27x minus 6y equals 42. Now when I add them up, I get the cancellation in the 6y is canceled out. 35x equals 70. Divide by 35, x equals 2. And I plug back into here. You can plug back here. 4 times 2 plus 3y equals 14. 8 plus 3y equals 14. Subtract 8, 3y equals 6. Divide by 3, 2. So the order pair is 2, 2. 33. The original was like this. 3x plus 2y equals negative 1. 6x plus 4y equals 0. All right, so I want to match up either the x or the y. This time if I multiply by negative 2, they both match up. So negative 2 times the top equation becomes negative 6x minus 4y equals 2. Leave the second one alone. Add them up, x drops out, y drops out, I get 0 equals 2. If you get a statement like 0 equals 2, that's no solution, that's impossible. Okay, graphically, what that means on the graph is that the lines would be parallel. And finally, 37, they give us these weird fractions again, unfortunately. So I like to clear the fractions. So top equation multiplied by 6. Bottom equation also multiplied by 6 to get rid of the 2, 6, and 3, and the 3 and 6. So 6 times the top equation, 6 times the bottom equation. So 6 times that is 3x. 6 times 1/6 is 1, so plus y. 1/3 of 6 is 2. 6 times that, negative 6x. 6 times negative 1/3, negative 2y equals negative 1. All right, so again, it looks a lot nicer now. All right, so I will multiply the top equation by 2 to eliminate the x and the y. 6x plus 2y equals 4. Copy the second one. Add them up. 0 equals 3. Again, there's no solution. Okay, now, there were no examples of this, maybe the next section will, but if you ever get something like 0 equals 0 or 7 equals 7, etc., that's the case of infinitely many solutions. That would be the case where the lines coincide. The lines lie one on top of the other. Okay, this one, no solution, no solution. The lines are parallel. Okay, I think the next section we'll see some instances where you get something like 0 equals 0, 7 equals 7, 23 equals 23. That would be infinitely many solutions. Okay, so this is section 4.2.